Hey guys, this is the video for Spiral 24 review. Anybody in my C block class want to say hi? That was Jay. Anybody else?
Hello.
That was Chris. Okay. Now that we got that out of the way, we're going to start off with exponential and logarithmic equations. And at first, I've got an exponential equation that I've got to get everything in terms of the same base. I'm going to go as small as possible. In this case, that's converting everything to base 2. 64 is the same as 2 to the 6th. So that would be 2 to the 6th to the 3x minus 1. 8 is 2 to the 3rd, and that would be to the x minus 4. Then multiply by 2 to the 3rd. I'm going to use some exponent rules to combine things. A power raised to another power. You end up multiplying those, so you get 2 to the 18x minus 6. Multiply those. 2 to the 3x minus 12. And if I'm multiplying two things with the same base, it means I'm adding the exponents. So to this, I'm going to add that 3. As soon as we have things in terms of the same base, we can set the exponents equal to each other. So we get 18x minus 6 is equal to 3x minus 12 plus 3. Combining like terms, I get 15x on the left side. And on the right side, we've got minus 9 plus 6 will be minus 3. X is going to be negative a fifth. For the next problem, we've got negative 3e to the 2x plus 3 plus 6 is equal to 33. First thing I might want to do is get the exponential piece by itself. My goal is to get that by itself and convert this to log form. And just as a note, this is actually supposed to be plus 3e to the stuff. And on the problem over here, that should be a plus as well when we get there. Okay. So we're going to have minus 6 to both sides, 3e to the 2x plus 3. And again, I'm going to put a box around that just so I remember to keep that and aim for having that by itself. And that's equal to 27. Dividing by 3, we get e to the 2x plus 3 is equal to 9. And now that I've got this by itself, I'm going to convert this to log form. Here's my base. This is log base e. Here's my answer. That goes on the inside. And my exponent goes on the other side, equals 2x plus 3. I'd like to remind you log base e could also be written as ln. So I could write this as ln of 9 is equal to 2x plus 3. To get the x by itself, we've got to subtract 3 and then divide by 2. So I'd write this as ln of 9 minus 3 is equal to 2x, and then ln of 9 minus 3 over 2 is equal to x. This also has a decimal equivalent that you could use, but you can keep it like this if you'd like. Writing it in terms of log base e instead of ln would also be okay. For the next one, we're going to work in a similar fashion but go backwards. I'm also probably going to convert this to log base e instead of ln, just to remind us what that looks like. But first I might divide everything by 2. So we get ln, or log base e, of 5x minus 4 is equal to 4. Converting this to exponential, we've got base e, exponent to the 4 is equal to 5x minus 4. Getting the x by itself, I'm going to add 4 to both sides. E to the 4 plus 4 is equal to 5x. Divide by 5, and I get e to the 4 plus 4 over 5 is equal to x. Last one of these, we've got 3 times log base pi of 2x plus 7 is equal to pi. I might divide by 3 first. And we get log base pi of 2x plus 7 is equal to pi over 3. That's my base, that's my exponent, that's my answer. So we've got pi to the pi over 3 is equal to 2x plus 7. And again, I got rid of that negative out front, that messed up the problem. So pi to the pi over 3 minus 7 all over 2 is equal to x. As a last comment on exponentials and logs, I'd like to remind you of a couple things. If you have something like 2 to the negative 6, that's the same as 1 over 2 to the positive 6, which in this case is going to be 1 over 64. The other thing to keep track of is fractional exponents. So if I've got something like 4 to the negative a half, well, that would be 1 over 4 to the half. But a fractional exponent can be expressed as a square root in the case of a half. So this would end up being 1 over 2. Fractional exponents always end up as radicals, and you can convert back and forth between them to help figure out what's going on there. Next up, we got an exponential log model. This is all about having money when you're old. So you've got $15,000 that you were given by a long-lost relative that you invest in each of the following scenarios. We've got to write an exponential equation to model each scenario and use it to determine how much money you have at the end of each scenario. In general, for any exponential models, we're going to use the same equation. We can use this for growth, we can use this for decay, we can use this for half-life if we know how to manipulate the equation. Here we've got a starting amount. We're going to have a final amount. And this is our growth or our decay rate. In the case of this problem, we're going to grow some money, and the last part we're going to lose some. So we'll look at how that applies. So you invest in a mutual fund that gains an average of 8% for 50 years. Okay, so that's t equals 50. My percent is going to be 8%, and that's my starting amount. So final amount is equal to 15,000 multiplied by 1 plus and 8% is 0.08. And the number of years is going to be 50. When I go and plug this in, if you bear with me while I open Desmos to do this. So 15,000 times 1 plus 0.08 to the 50. That $15,000 would turn into $703,524. And 19 cents for good measure. Second thing, you put the money in a savings account that gains an average of 0.25% interest a year for 50 years. I'd started out the same. A equals 15,000, 1 plus and 0.25% really means 0.25 divided by 100, or I'm going to move the decimal place 2 places to the left. That'd be 0.0025. 0025, and then that to the 50. And when I plug that into Desmos, we end up with 16,994 and 58 cents. I don't think it takes a finance genius to see that our first option with $703,000 is better than that 16,994. Finally, we've got a kind of double problem here. We're going to gain money for 30 years and then lose money for 20 years. We're going to do this in 2 pieces. So I'm going to call this A30, the amount of 30 years, is equal to 15,000 times 1 plus 18% is 0.18 to the 30. When I plug this in, we got 0.18 to the 30. We get that the amount at 30 years is 2150559.58. So that's over $2 million. Next, I've got to take a look at what happens over the next 20 years. So that's going to be my amount at 50 years is going to be my amount at 30 years. So 2,150,559.58. And then 1, instead of gaining, we're losing 10%, so minus 0.10. And that's for 20. When I plug that in, and thankfully on my screen I can just copy paste things. And when I do this out, so 1 minus 0.1, and that's going to be to 20 years, we end up with $261,457.84. Now we're looking at some trigonometry. So given an angle, and the only reason I have to indicate what's beta is between is because that lets us do this problem. You don't really need to worry about that. We've got cosine of beta is equal to 11 over the square root of 133. I've got to find a whole bunch of exact values. Let's make a triangle first. Okay, here's beta. Cosine is 11 over the square root of 133. And if I do some amazing work in terms of Pythagorizing, we get 133 minus 121 is 12. This third side would be the square root of 12. Sine of beta would be the square root of 12 over the square root of 133, and that would be fine. Cotangent of b, that's adjacent over opposite, that's reciprocal of tangent, is going to be 11 over the square root of 12. Sine of 90 minus beta, well, if this is beta, this angle up here is 90 minus beta, because these two have to add up to 90. So we're looking at 11 over the square root of 133. And then finally, cosecant of 90 minus beta. So cosecant of this top thing. Cosecant is the reciprocal of sine. So we're talking about hypotenuse over opposite. That's going to be the square root of 133 over 11. Next up, we've got Jimmy hiding in a tree. Andre sees him. Andre knows that he stands 50 feet from the tree, and the angle of elevation is 20 degrees. Okay, so we've got an angle of elevation that's down here, 50 feet from the tree. That should be Andre, but it's Andrew. Andre positioned a 24-foot ladder in order to have the top reach Jimmy. So I'm going to say that this is my ladder. And if I'm looking at something that I know the adjacent, I'm looking for the hypotenuse. All right, this is cosine of 20 degrees is equal to 50 over ladder. When I do this out, we end up with 50 divided by cosine of 20. And that would be an acceptable answer. If you'd like to actually get a number for this, I get something that I don't love the answer to. And that's because I totally did not read the problem. So this would be 53.2 feet. But that's not what this question is asking. This question is, where does a 24-foot ladder have to go in order to reach Jimmy, who's now stuck in the tree because I took too long? So then the first thing we might want to know is this side. And instead of using cosine, I'll probably use tangent of 20 is equal to question mark over 50. So 50 times tangent of 20, we get question mark is equal to 18.19 feet. So that gives me a second triangle I have to consider. That gives me a triangle based on the idea that we've got a 24-foot ladder. We've got an 18.19 foot tall Jimmy. And we've got to figure out, not that angle, I guess, but how far away I have to go. So to me, this looks like we're looking at a Pythagorean Theorem. So that would be x squared plus 18.19 squared is equal to 24 squared. And if I do that out, we're going to have 24 squared is 576 minus 18.19 squared. And we get x is equal to 15.65 feet. So Andre would have to put the ladder 15.65 feet away from the bottom of the tree. Next up, we've got a fun problem where I've had a triangle being broken into two pieces. I know some angles, and I've got to figure out x in the bottom. To me, this kind of looks like I've got to solve for two separate pieces first in order to get that total thing. And that at the end, we've got x is equal to a plus b. So maybe going for a first. And looking at this angle of 18 degrees, we've got an opposite that we're looking for. We've got an adjacent that we know. So tangent of 18 degrees is equal to that number a over 7.2. In doing that out, we get 7.2 times the tangent of 18. And I get a equals 2.34. To find b, we're going to use a similar thing with tangent of 31 degrees, which is b over 7.2. So 7.2 times tangent of 31. And we get b equals 4.33. When I add those together, we get 6.67. And that's equal to x. Finally, we've got a guy looking at a sine. And what is going to happen here is we're going to end up with two right triangles kind of nested on top of each other. We know that both have a base of 5 feet, and that the bottom of this is going to be 42 degrees, and this whole thing is 52, so that would be 10 degrees. We'd like to figure out how tall the sine is, and in doing this, it might be nice to draw these two triangles separately. So this would be 52 degrees, this is the big triangle, 5, and let's call that y. This is the small triangle, and let's call that x. This would be 42 degrees. So looking at this, we're looking at a tangent of 52 is equal to y over 5. So 5 times tangent 52. Y equals 6.4, and that's meters. Same thing for the bottom one. Tangent of 42 is equal to x over 5. 5 times tangent of 42 is going to be 4.5. So I know the whole thing is going to be 6.4. I know the bottom part is going to be 4.5. To figure out the height of the sine, I've got to subtract those two. 6.4 minus 4.5, that's going to be 2.4 minus another 0.5 is 1.9 meters. Last up, we've got the law of sines, law of cosines. First thing I might want to do is to figure out what I'm looking for. So in this triangle, I'm trying to find BC, which is this side up here. The only piece that I know is over there, that's B. That's A and that's C. I know two angles, I don't know the third angle. But I can use the idea that triangles have 180 degrees to figure out this has to be 89 degrees. Now that I know this, I'm going to check law of sines first because it's shorter. And it looks like I have a winner because I have a pair of opposite side and angle. So sine of 89 over 32 is equal to sine of 30 over A. I'm doing this out. Sine of 89 divided by 32 is going to be 0.0312. And that's equal to sine of 30 is 0.5 over A. Multiply both sides by A, we get A times 0.0312 is equal to 0.5. Then I'm going to divide 0.5 by that number, so 0.0312. We get A is equal to 16.025. Next up, we're trying to find AB. In other words, that's C. Okay, check law of sines first. In this case, I don't have enough information for any of the three sets to use law of sines. So we're going to use law of cosines focusing on C. So C squared is equal to A squared, 25 squared, plus B squared, 29 squared, minus 2 times 25 times 29 times cosine of 130. When I do this out, we've got 25 squared plus 29 squared minus 2 times 25 times 29 times cosine of 130. I get 2398.04. Take the square root of both sides. And we get 48.9 is equal to C. For the next one, we've got to solve the triangle. That means I need all sides and all angles. Let's draw the triangle first. We've got KHP. K is 53 degrees. 35 yards is side K. P is 37 yards. I don't know angle P, and I don't know side H. I do have an opposite pair, so I might be able to use law of sines for this. So sine 53 over 35 is equal to sine of P over 37. When I do that out, we get sine of 53 divided by 35 times 37, and I get sine of P is 0.00. Nope, that's sorry, that ended up in the bottom of the fraction. Times 37, so we get 0.84, there we go, that's better. 0.8442. Inverse sine to both sides. And we get an angle of 57.586. I can use that to get my third side. And 180 minus that. $57.586 is going to be 122. By the way, I forgot to minus 53 from that. Whew, that was bad. It's going to be 69.414. That was Carolyn, by the way. She says
Sorry
hello.
to everyone, and hello.
So that means that angle H is 69.2414. Finally, I could use law of sines a third time to get that last unknown, which is side H. So sine of 69.2414 over H is equal to, and we already did one of these out, and that ended up being something gross, so let's just write this as sine 53 over 35. So we got sine of 69.2414. That's going to be times 35 divide by sine of 53. That's giving me an error. I don't know why. There we go. We get 40.979. And for our last problem, I don't know why it's called problem number 4, because this is definitely not problem number 4 in the spiral review. We're looking at another triangle. This time we have three sides. We have nothing that lets us do this using an opposite pair, so we have to use law of cosines. I'm going to arbitrarily choose B to start this out, and I'm going to write this as 25 squared is equal to 26 squared plus 19 squared minus 2 times 26 times 19 times cosine of A. First thing I have to do is to get these pieces together. 25 squared is going to be 625. 26 squared is going to be 676. 19 squared is going to be 381. And 2 times 26 times 19. I added too much stuff in there. It's going to be 988. Okay, tricky part is right here. We cannot combine this with the other stuff on this side because they are not like terms. So what we're going to have to do is combine these two, and we get 625 and 676 plus 381. We get 1057 minus 988 cosine of A. I'm going to minus 1057 to both sides, so 625 minus 1057. We get negative 432 is equal to negative 988 cosine of A. Divide by negative 988, so negative 432 divide by negative 988. We get 0.4372 is equal to cosine of A. I'm going to take the arc cosine or the inverse cosine of 0.4372. And we get our answer. So let me just put parentheses around that guy and do arc cosine. I get A is 64.07 degrees. One of the things that we can do with this now that we have an angle is now apply the law of sines, which might be a little bit faster. So we do that as sine of 64.07 over 26 is equal to sine of B over 25. When I do this out, so that's going to be sine of that 64 number, 64.07, and we're going to multiply that, or I'm sorry, divide that by 26, and then we're going to multiply that by 25, and I get 0.8647 is equal to, I don't know why I'm over here suddenly. That won't let me move it. 0.8647 is equal to sine B. If I do the arc sine of that, putting some parentheses around it, we get B is equal to 59.85. And finally, if we do 180 minus 59.85 minus 64.07, we get our final answer of C is equal to 56.08 degrees. Whew! And we are finished. Say bye, everybody.
Bye.